Sketch the region bounded by the curves and find its area. So we have cosine x and 2 minus cosine x. First we'll sketch cosine x. Label some coordinates here. So we know cosine x looks like this. And then 2 minus cosine x, that's going to be a transformed cosine graph. So we shift it up 2 units and then we reflect it. So that should look like this. Going with a very rough sketch here. And we're wanting to find the area that is between these two curves. So looking for this shaded region here. The area is the integral from 0 to 2 pi and we have the upper curve, which is 2 minus cosine x, and then we'll subtract the lower curve, cosine x dx. Simplifying this, we get the integral from 0 to 2 pi of 2 minus 2 cosine x dx. And now we can integrate. This will give us 2x minus 2 sine x from 0 to 2 pi. Now, evaluating that, we'll plug in the upper limit, 2 times 2 pi minus 2 sine of 2 pi, and then we'll plug in the lower limit, 2 times 0 minus 2 sine of 0. This will give us 4 pi minus 0 minus 0 minus 0. So our area is 4 pi. In this example, we again want to sketch the region bounded by the curves and then find its area. So we first have the square root of x minus 1. If you're familiar with the square root function, that's just your basic square root function that's been shifted right 1 unit. If you don't remember transformations, we can use point plotting. Plug in 0, we get the square root of -1, which is an imaginary number. We can't use that. Plug in 1, we get the square root of 0, which is 0. And then plug in 2, we get the square root of 1, which is 1. And then the curve will look something like this. For this graph, it may be beneficial to isolate the y since this is a linear function. We'll get y by itself and put it in slope-intercept form. Once it's in slope-intercept form, it's a little bit easier to graph. And we have the region now. We're looking for the area of this shaded region between the curves. To find the area, we will integrate from 1 to 2. And we'll start with the higher function. square root of x minus 1, and we'll subtract the bottom function x minus 1 dx. In order to integrate this, it's going to be beneficial to use a u-substitution. We'll let u be x minus 1, and then the derivative of u is 1 dx. So rewriting this, we have the integral of the square root of u minus u du. And then our new limits of integration, we want to plug 1 into u. 1 minus 1 is 0. And then we'll plug in the upper limit of 2. 2 minus 1 is 1, meaning we're going now from 0 to 1. Now we integrate, we get 2/3 u to the 3/2 minus 1/2 u squared. And we're evaluating from 0 to 1. We'll go through and plug in the upper limit. 2/3 times 1 to the 3/2 minus 1/2 times 1 squared. Then subtract, go through and plug in the lower limit. 2/3 times 0 to the 3/2 minus 1/2 times 0 squared. This gives us 1/6, the area between the two curves.